everyone, and welcome to today's webinar, Securing AI Success, the Critical Role of MLOps. I'm your host, Mike Teeling, and I'm really glad you could join us. Over the last few years, AI has moved very quickly from initial experimentation to now higher expectations. Many organizations have built promising models, launched pilots, and explored Gen AI use cases across the business. But there's a challenge that many teams are now running into, and it really boils down to this. Building a model is not the same as building a reliable AI system. A lot of AI initiatives show early promise in the lab, but then they struggle once they hit production. Performance drops, costs rise, data changes, and outputs become less reliable. And in Gen AI systems, a whole new set of operational risks are introduced by prompt behavior, retrieval quality, and those pesky hallucinations. That's where MLOps becomes critical. MLOps helps organizations move from isolated AI experiments to AI systems that are production ready, scalable, governed, and perhaps most importantly, continuously improving. To help us unpack this really important topic today, I'm joined by two experts from Talentica Software, Alakh Sharma, who's the principal software engineer for data science, and Ratnesh Parihar, he's the principal architect at Talentica. Alakh and Ratnesh, welcome. Oh, you guys are muted.
Hey, hello everyone. This is Ratnesh here.
Hey, yeah, hi. Great. Thanks, guys. Hey, it's great to have both of you guys here today. Thank you. So let's take a quick look at today's agenda. So over the next 45 minutes, we'll cover these following topics: why AI fails in production, 5 must-haves for production-ready AI, the how-tos of MLOps architecture, operating AI and GenAI in production, and then we'll finish with some real-world success stories. But before we get started, I wanted to go over a few quick housekeeping items. During today's session, we'll be conducting a couple of pop-up polls. Now, your participation is optional, but we really love to hear your perspective on our topics today. And we'll save some time at the end for a Q&A session where you can ask questions directly to our speakers. So please submit your question at any time using the question button there on your Zoom toolbar at the bottom. And finally, playback of this webinar will be available on demand. We'll send the replay link as well as the results of our poll questions to your registration email after today's event. So with that, let's get started. Alakh, it's over to you.
Thanks, Mike, for quick introduction. But before jumping into MLOps, let me quickly share my observations, whatever I've seen. Most AI systems don't fail because of the model we build, because sometimes whatever we are building, it's working good offline and all sort of things. But they fail because of everything around it. So we will discuss those issues one by one. First issue is data. We train on clean data. When I'm saying clean, it's curated, just specific for that use case. It's kind of pre-processed, whatever the missing values, whatever we are filling just for that specific use case. But production is data is messy. That's kind of unpredictable and constantly changing as well. So even if our model is great, it's performing good, the inputs it sees in production kind of completely different. Like when we are using some features, whatever features we are using for training, whatever the data distribution we use for the training, but because of the change in production, it completely changed. The data distribution and inputs are completely changed. And because of that, performance usually drops in production. And everything around it, things kind of start breaking on. Second, like kind of main use issues or pain point is everything, whatever we build, kind of work great offline mode. When in developer language, let's say it's great in notebook, but not in production. Because production comes with constraints. Constraints like latency, scale, integration with outside APIs, third-party integrations, with the different module integrations. And suddenly, which model it was working perfectly offline now becomes too slow. With slow, with the latency, different computation devices, it required like not just slow, it can be expensive also, and which will be hard to integrate. So that is kind of whatever the offline model which is working well in offline kind of environment, now with the production environment might not be good. Third, and the kind of dangerous one is lack of visibility. So most of the systems which we build uh, don't have proper monitoring. When I'm saying monitoring, it monitoring means for AI system is whatever it's doing, whatever responses it's generating, input it's generating, is it correct or not? It should be continuously monitored. It should continuously monitor, right? So when things go wrong, like a model is not performing, getting negative feedbacks from users, uh, whatever like negative things, even positive things from users point of view or from model point of view, from the data point of view, it is changing, but we are not getting any trigger. We don't know what's going on under the hood, right? So they don't fail like kind of loudly, they just fail silently because we are not continuously monitoring those. Performance will continuously drop because of these changes, quality will degrade. And now when we are getting feedbacks from user because of these performances, it's too late. So that's why this is like a dangerous one if we don't have much of visibility in the production environment. And finally, the systems, AI systems which we are deployed, mostly it deployed just once and left as it is. Because production is not static. We need continuous updates, retrainings, whatever the knowledge it has, it should refresh based on whatever the latest things going on. Whatever patterns it's changed, it should adapt to those patterns. Without that, even a good system, which is working, because features are changing, user behaviors are changing. So if you look at it, whatever these failures we talked about, these are not random failures. They come from like kind of missing capabilities across data, systems, monitoring, and continuous feedback loop. And that's exactly what MLOps is trying to solve. So if these are the reasons AI system fail, whatever we discussed the pain points. Now the most important question is, what do we actually need to like make this work in production? You can think of these five must-haves for five core capabilities. Every AI system, production AI system, we can say, should must have. We divided these five must have in two parts. One thing is the data in pipeline thing, and second one is reliability, scalability, or we can say in production part. So data in pipeline, which we can say training or like development phase, and reliability and scale is we can say production phase. So let's talk one by one. First is reliability. Reliability in data in pipeline. When we are talking about the data in pipeline, we need consistency between training and production. Same feature should be there in training and same feature should be there in while in production. And especially with the LLM system that includes prompts, embeddings, retrieval pipelines, whatever we evaluated on, it should exactly be the same on production environment. Now, tracking whatever we experiments, we usually have multiple experiments for trainings, right? Or while building the models, tracking all those experiments, maintaining all those versionings, then which will help us to decide which experiment or which version should go in production, which worked well, and why we made the decision for production. All those things should be like in the versioning phase, and based on that we can make the decision, and it's consistent also between development and deployment. Second is validation. It's not enough to data move data from we can say whatever the raw features we are getting to the model input. Moving data from end user to API calls as input to model input. So we need to trust that data. So for that, if we have to trust, we have to make sure that whatever validation schemas, anomaly detections, uh, whatever the we are ensuring that system is getting correct and relevant inputs, then it will make sure that our model will give correct response. And when we are talking about the validation, it should like whatever it's trained on. Third part is monitoring. So for monitoring, we need monitoring means kind of visibility again, which like whatever the data is changing, outputs, inputs, whatever it's changing, business KPIs, latency, performance, all those whatever metric we are following, if it's changing, it should trigger the signal, which will help us in feedback loop, so we can update our model. And that come with fourth thing, continuous updates. If model degrades over time, we need retraining pipelines. So why model degrades? Model degrades because of data drift. Drift is a change in data where it's as I already mentioned, distribution for training and prediction is different. Change in features, change in model responses. All those things, if we are changing, the model performance degrades. And with the modern AI system, this also includes when I'm saying modern AI system is like a whatever the GenAI LLM things. This includes updating prompts, knowledge sources, also continuous feedback mechanism from end user. So if those things are changing, then we should get trigger from the observability phase, and in the retraining we should or refreshing we can say for the knowledge basis, it should adapt all those changes and should push to the production environment. So it kind of adapting all those changes and new changed behavior from the user or feedbacks. Finally, serving. Uh, when we deployed everything, everything is working great. But AI system still fails because of if it's too slow or it's too expensive. If it's too slow, people will not will be able to use it, right? They might have to wait for a few minutes just for chatbot responses. No one will wait for that. So we need to optimize for latency, cost, as well as the scalability. So if we think about it, production AI system is not about just a single model. It's about getting all five layers, uh, all these five layers right. And these five layers combined POC phase to experiment tracking phase to versioning to development, then monitoring, taking production signals as input, trigger pipelines, and while deployment, taking care of scalability as well as the serving. Now let's see how these actually come together in real MLOps architecture. So MLOps is essentially a loop of three stages: build, deploy, and observe. So when we build, we do multiple experiments with the tracking, which we already discussed, and whatever the metric we followed for offline evolution, which will make sure it's ready for production. And once model is ready, we deploy by handling infra or maybe other parts, packaging, CI/CD pipeline, and other aspects. But the key difference from traditional system to the is the third step, which is like kind of observe. Once the model is live, we continuously monitor performance, detect drift, and collect all those feedbacks. And when this feedback is what closes the loop, it feeds back into the build phase where we adapt all those changes, uh, kind of improve our model's performance, and continuously push to the production. So instead of one-time pipeline, this becomes a continuous learning system. So let's start with build phase, where everything begins from the raw data. This is where we kind of prepare foundation. We create reliable data pipelines, engineer features, engineers prompt, build retrieval systems, and all those experiments we have to track, version, all those things. So when we will version, so we can trust this. Also, we will know what all changes we did with each version. So we can reproduce whatever the results we were getting each time the same, and it will be consistent. So the offline evolution will be better. And whatever the offline evolution we are doing based on the metric, and based on that we can decide like this version or this experiment is ready for production or not. So these experiment tracking data, code and model, all those things like a standard software is just a version mostly the code only. But for the AI systems, MLOps systems, it versions code, data, and model, all three things together. And for this, all the GenAI stuff, the prompt embedding, whatever the APIs we are using, latest model or not, which model version we are using, all those things come under the version tracking. Whatever the transformation we are using, it's also whatever the feature engineering we are doing, whatever the data pipeline we followed, how we curated the data, everything will come under this one version. So goal here is not just to build a model, it's to build something that is kind of reproducible as well as the reliable. So once we have this good model, the next challenge is getting it into production. This involves packaging it, setting up CI/CD pipelines, and then exposing it to through APIs. But deployment is not just about making it work. It's also about making it's kind of scale reliably and kind of which can handle real world traffic. So we also have to optimize whole this AI system in production for latency, cost, this scalability, because production systems have some constraints. So deployment is where we can say a model is transitioning from an experiment phase to production phase, where product facing system we can say. So experiment to product facing system. So for example, we build one system for real time bidding domain where constraint was serving request under 10 milliseconds. So we build that system which can handle 50 billion requests per day with the constraint obviously the 10 millisecond per request under 10 millisecond. So those type of things, whatever the constraints mechanism and the real world traffic we can get from requirement in production scenario, we have to take care of all those things. So overall deployment is not just about building model, but it's about serving well also. Now comes the most critical part, which is observed and often overlooked as well. Once the model is live, things start changing because we whatever we did till now, it's kind of in our control. Whatever the data we are getting, how we curated it, how we used in the training phase, and how we build that. But once it's in production, we don't know what kind of data we will get. It is a high possibility that data will change, user behavior will change, and the performance might drop. So we have to monitor not just system metric, but model performance as well as the business KPIs as well. We have to detect the drift. Here, drift is not just about the data, but the prediction, responses, latency, all those things. We have to collect all the feedbacks. This is what tells us whether the model is actually working in the real world or just not just like in offline evaluation mode. So for example, like in one of the project for automobile industry, we built one dealer performance system where features were like sensors, geographically informations, income information, vehicle information, and these information were like refreshing every quarter. Some of the information might be every year and sometimes in every 5 years based on the different features. For that, we build one pipeline which can detect change in data, how what percentage of the data is changing. If it's like just 1 or 2%, we can ignore it. But if it's going beyond that, like let's say 10%, more than 10%, then it triggered that pipeline, which pipeline is kind of pre-processing the data, building model, evaluating it, and if it's better means like more than threshold, which is from the existing model performance, then we just deploy that. This whole automatic pipeline itself is deploying that in production as well. That's why we need continuous observation to detect change as well as the update models. Now, as system scales, another layer becomes critical, which is governance and security. This is the layer that sits across everything, not in just one module. It will be build, deploy, as well as the observe. So this is not a separate step, but embedded into every stage. Like first in build phase, if our data isn't controlled, uh, model might be at risk. For that, we have to handle data privacy, PII handlings, personal identifications, all those numbers should not be in model. End users consent which data we are using, who used what data, model lineage, and we can say bias and fairness, all those checks before training it. So this is about the build phase where we have to take care of governance, security, all those things. Secondly, in deploy phase, or we can say the production phase, governance becomes control. Like who can call the APIs, rate limits, authentications, right? And approval workflows for releases, for version controls, and maybe how we can handle it like prompt injections, misuse of our APIs, so which can kind of increase the cost, right? So overall, who can use the model, how much, in what way? That needs to be tightly managed. Also about the security here is not just about protecting the system or business. We have to protect both. And finally, observe phase, where governance becomes visibility. For example, who did what and when, right? We need to know about that. So we can trace it back. Monitoring all the harmful, unsafe outputs, or maybe users' feedback, we can filter that out there. So all those feedbacks we have to take. Then the feedback loops with all those traceability, we need to know what things going wrong and because of what, and able to trace it back fully. So like overall, strong MLOps isn't just about all those model shipping or maybe faster shipping. It's about ship them responsibly, securely, also with full control. So we know what is happening and because of what reason we are getting wrong responses or some issues. So we need full traceability. We also need strict access control, secure APIs, especially when dealing with the sensitive data. And all of this has to run on a scalable platforms that supports training, deployment, as well as the monitoring. So this was overall MLOps architecture and its core components. Now I'm handing over to Mike for poll question.
Wow. Well, thanks a lot, Alec. That was a really good walkthrough of all the steps that are necessary to create MLOps architecture. I think it was especially important to hear how governance and retraining and continuous improvement they really become critical once those systems become live. So, okay, guys, it's time to move on to our first poll question and hear from our audience. So you'll see a poll question on your screen. Where does your organization currently struggle the most in operationalizing AI in production? You'll see a pop-up with a number of choices for you. You can choose whichever one is the most important for you. We have monitoring and observability, deployment and scaling, data pipelines and validation, retraining and continuous improvement, GC and explainability. And then you can also option of, we're still in experimentation if you're not yet in production at your organization. So we'll pause a little briefly here for you guys to put in your responses. Great. Thank you so much for sharing your perspective. And again, we'll share these answers with you after we wrap. So it's really interesting to see how many of these challenges can complicate the process of operationalizing MLOps architecture. In many cases, teams don't struggle just in one area. They can experience gaps in multiple stages, which is exactly why a holistic approach to MLOps becomes so important. With that in context in mind, let's move into how organizations can apply MLOps against Gen AI in practice, including hearing about some available tools. So with that, Ratnesh, over to you.
Okay. So hello everyone. What I'm going to talk about is in a very simple words, what exactly one MLOps engineer does. Okay. So the very first thing is what's his perspective, how his days looks like. So the very first thing he do as a part of his the monitoring, as I said earlier, uh, he will come to his desk and primarily he will start looking into the multiple dashboards, and essentially he will go and check accuracy, drift, and latencies. He will go and figure out if there are any alerts, and also he will check out the any CI/CD pipeline issues. The very next thing he will do on the midday time is a normal mundane work where he will talk with uh, data scientist to thinking about the next set of things. And next part, he will work with the engineering team to work on the APIs, infra and scaling side. Third part is the pipeline improvement. So pipeline is something is completely owned by the MLOps person. Infra might be someone else, but he at the end need to be the pivotal role who will collaborate everything, engineering, data science, and working with the DevOps persons. So the next part is work will be like in afternoon. Primarily is where the most of the time will go. But essentially, what he will do, he will deploy new model. And in term of the traditional engineering, this is little different because in the traditional engineering, we don't do majority of deployments in a very quick span of time. But in a MLOps, we do deployment every day. We do deployment because there are a number of uh, versions of model which we need to run. We need to simulate a lot of previous data to see if no regression is happening. Third part is once it is live, uh, you need to test with tons of prompts, so making sure that whatever has been coming to the user don't get hallucinated. Okay, so that's why this all ABC testing does happen. So this is like uh, lab work he do. And then the end of the day is most of this is the reporting part. So he will go and check the any compliance and audit violations. He will figure out KPIs which are relevant to the businesses, not the engineering or the DevOps perspective. He will figure out those. Primary business matrices are cost and hallucination. So these are the people very keen about it. And then the third part he do is the next set of improvements. So he will broadcast the whatever observation he did at the end of the day. Maybe he go and publish those set of improvements. So as I said earlier, this is the bugger who drive majority of the thing. So with MLOps person, one of the key thing is guarantee is the faster delivery. And as I said, majority of production system are multi-models, multi-AI system, multi-agent with the agents and number of versions. So you need someone who can do very fast delivery, maintain different versions, of agents. He will be the someone who understand. You need at least one person who understand which agents are running, with what version they are running, okay, and who is tracking majority of the traffic, who is uh, doing the hallucination. So he is someone who can do this tuning part. And as the MLOps folk, when he start in a project, the initial 1 2 months are very critical because he need to set up all this dashboard configuration, runtime, tuning parameters, feature enhancements. All he need to move from engineering to operations. Okay, and that's why this role is very key, because it's enable you to do that. Okay, so the moment he will join the team, he will start looking into these aspects, and he will start moving all this to the operation side, so that day to day he can go and start. So once that thing is done, he will start doing the monitoring and all those stuff. Okay, deployments. So he will, as I said earlier, he will do the continuous improvement of the system. He will completely reliable, responsible for managing data drift. And I will give you the demo as well, how actually these things look like in the actual production system. And then he will also, for the enterprises, governance and compliances are important and more than important. So he need to make sure that every audit, who accessing what data, is at least at the very base level is available. So now coming back to the tool and technology. So here are some of these tools category wise. Like in monitoring, we have these tools. For the experiment tracking, MLOps person with the DS team or the AI team, he build multiple experiment. But essentially, people like to track, okay, which experiment is working, what version is working, and they like to do the tuning as well. Then the feature store. Basically, one of the key concept is you have to have the features, like if you're doing a payment fraud, right? So age, sex, demographic data is all your attribute, which essentially enable you to do the fraud detection, number of transaction, if you want to figure out any organized frauds, right? So these are the features. Essentially, you look into the data, figure out the data, and then you build your features. So you don't need tons of features, you need some very good set of features. Okay, and there are tools who does this, make your life easier. So it's not that you need to go and do everything from zero to zero. Another, data quality. So one of the key responsibility for ML of person, making sure every data stored, whether be it a data warehouse, be it a data lake, it has to be completely clean and it has to be completely reliable, so that AI team or DS team can go and directly consume it without thinking of cleaning it, because this is very time consuming, and these are the tool who will help you a lot. So instead of writing your own Python code to go and do this, they will make your life simple. Now in the deployment part, as I said, there will be multiple agents, their versions, multiple models will run, and it could go mess as well. So you need some technology to help you. So these are the tool. Same goes with these are the most important ones. Someone which start with this, you need to, because you don't know how the people will use your system, but still before going into the live, you need to make sure that it is work properly. And this is where the problem get started. It's like chicken egg. If you don't do anything, you will come into damage control situation, and then you start fixing it. So here you need some tool who can simulate tons of user combination prompts, hallucinate the whole system, and then there has to be some tool who can properly analyze those things and help you to fix those things. Okay, so these are the tool which can help you on those part. Now talking about the tool, the next thing is I like to give you some real world showcase how the people or ML of person work day to day. So in order to do that kind of level of production gate system, the very first thing you do is what we call as a drift monitoring. So this is one of our production system which we use for fraud detection. Primarily, as I said earlier, fraud, what is the drift? So if you build the features, by once after some time, these features start giving you drift, means they don't contribute much on the fraud detection as the time progress. So you might need more features, or you might need to ret retrain the model, or you need to tweak the whole system out basis on how this parameter performs. Okay, so right now you can see this didn't perform well. Even in the just 5 transaction ago, this credit score didn't work. For current transaction, this thing, three thing didn't work. Also, the new upcoming transaction, these three things didn't work. So as a MLOps person, for me, I will go into the history and start showing what are the typical scenarios where these features don't work. So I can collect that data, and maybe we can improve this, or maybe we can bring new set of features. Okay, so this is the very first thing someone does. Another, as I said, people do the experiment all the time with the different model and version. So like in this fraud detection system, right now these four models are deployed in the production. Primary one is one we have used is a classical ML model using XGBoost. Another is LGBM, is version 2 is running on. Another is random foster, and another is we have used the neural network. So there, these are the four primarily are working, and you can see how many fraud has been detected in like last 2 3 days. And these are the high traffic scenario, because this system taking like 1 million transaction per day. So this velocity is very high. And there are, so here you can see which models are performing. So you can see their ranking, how they are not performing. So looking into this, you can definitely see neural networks. This version is not working, but this combination is working pretty well. But our hero is again light GBM V2, who is detecting majority of things and working very well. Next thing is deployments. So you will see what has been deployed with the what version, and this is MLflow is the tool which will help you on this part. Sorry, didn't mention the tool's name. So for the drift, this is called Fiddler. For experiment, this is called Neptune. For this is MLflow, where you can do all the deployment and see if they are breaking, how many times they have restarted, normal latency. Okay, so how much precision they have, how much recall they have. So all these things you can drill down and see. The last part, and maybe the most important, and where even before the production and the post production, majority of your time will spend. Uh, so what you will do as MLOps person, when you will start your hands on a very pretty new system, you will put lot of prompts into the system. Okay, so you will use like prompt foo to generate maybe thousands and tens of thousands of prompt. Okay, so prompt foo as a tool automatically generate those prompts for you, and it try to do the simulation a lot. But at the end, it's your thing to monitor each and every response. Okay, so primarily you can select any of the latest requests. You can see what was the prompt, what was the system prompt, what was the user prompt, how much time it took, what was the quality, what was the cost, and the latency, whether it take 3 seconds, 4 seconds. The most important point, how accurate and how relevant it was. So like in airlines case, the the better version of the bot, if you see, you will see a lot of greens and yellows here, because they will not put a lot of time over there, and their overall number of token will be less, cost will be less, and you will get a lot of success here. So this success is happening because this is running for like 1.5 year. But once you deploy for the very first time, majority of these will be red, and it has to be, because you are simulating your all attacks. I would call it as attack, because you want the system to get hallucinated, and you want them to get fixed. So you will see a lot of error here, and then you go back and fix primarily your prompts, system prompts. You will do the versioning of it. And another thing which we kind of using here is uh, yeah, so like this. So these are the agents, right? So since you like to have the better control of the whole system, one of the key thing you can do is, instead of maintaining and asking engineering team to do that, this is completely on your control. So if you see anything hallucinated, you can go over here and you can quickly fix the prompt, and then you can start seeing the next set of requests, whether these are working or not. So their definition you can on the runtime, you can go and fix it. Okay. So this is, so I'm done with the demo now. And if you have any question, please put on the chat. We will answer it. So now, just talking about the production system very quickly. So it's all about setting up the guardrail, prompt enrichment, context management. As I said earlier, right, the airlines example, right? In the first case, it was not working because they were not managing the context. In the second version, they were very smart. They know the context and they were handle and making sure that product is strong. Okay. Same goes with the guardrail. You don't want your chatbot or AI features to do the thing which is not required. Behind the scene, everyone uses OpenAI and all this model, and they are kind of very strongly protected. They have tons of layers of reinforcement, so you don't need to worry about that part. So only thing you need to worry about your thing. So if someone asks you for something and if you don't protect your output and input system, then there might be some problems. Same goes with the multimodal. You need to check the cost, quality, and speed. Cost can exponentially grow, so you need to keep a very keen eye on it. And last part is the privacy part, the protection part. So here, three things is crucial from the system integrity, building trust. And as I said earlier, in order to build the trust, you need to attack the system, making sure it doesn't hallucinate. Every response has to be correct. And the second example of airlines has to be your target. You don't need to provide tons of input from the user. Your agent or AI system has to be smart enough to get all this information internally. Incident detection, incident will happen. It's supposed to happen, and you need to proactively uh, create the incidents. Okay, and then you need to using the chain of thoughts. You can kind of do the full traceability in the multi-agent system, and you can fix them. And you can only fix them if your configuration tuning, all these parameters, prompts, right, are kind of accessible to you. Is in runtime you can go and fix it. You don't need to do the model deployment or the AI system deployment. So most of the tuning fixes happens on the runtime. You don't need to do and deployment all the time to fix it. So you see the error, you quickly change your system prompt, and that's it. So that's how it should be. Now, this is one of the thing how people are transitioning from MLOps. And one of the key role which is transitioning is the data engineering. Okay. So for a particular data engineering and the people who are aspiring big data or working on the big data, and also some person who are on the infra side, they are interested in moving their career. So they are also coming to this segment. And essentially what happened, right? This, why I'm talking about data engineering, because this evolution is natural. Data engineer are the person who understand features, dimensions, facts, business. Most important part is the business and how the data drive the business. This is the natural for them. The only thing, AI is undeterministic. All this AI tool I talk about it, chatbot, they are all not deterministic. So it's very hard. So you need to make sure your mind set get changed. And this is where this skill agency come into picture, because now you start looking into different aspect of the skills which are kind of non-deterministic. Okay. And they can generate the business demand as well. So we know a good AI tool can make a tons of difference. There is effort required to do that, but some data engineers who are already working your team or in your system, for them it should be the natural. Okay. So here this is the part where they can do the transition. So now we will talk about this poll 2 by the mic.
Great. Thank you very much, Ratnesh. That was awesome. It's very helpful to think about the entire operations process because I think it highlights something that we see at Talentica all the time, which is that production AI isn't just about how good the model is; it's about operational discipline. So honestly, this is where Gen AI and MLOps need to meet. A Gen AI builds the intelligence, and then MLOps makes sure it actually works and that it doesn't break in production. So before we move on, guys, let's go on with our next audience question. Check in with our audience for our second poll. How mature is your organization's MLOps Gen AI operations today? So you'll see the choices there. Go ahead and pick one. We'll take a few minutes for you to read through those and submit your response. Great. Thanks, everybody, for providing your input. I think this just shows you how wide the maturity gap is across many organizations. Lots of teams are moving fast with AI, but the operational foundation often lags behind. So closing that gap is what ultimately determines whether AI initiatives scale or if they stall out. So the question is, what does this actually look like in practice? In this final section, Ratnesh will walk us through a few real-world examples of how MLOps is delivering measurable business impact. Ratnesh, back to you.
Okay, thank you, Mike. So now I will talk about some of our success stories which we have done, where again these stories are completely uh, uh, not by the MLOps, but MLOps played a huge role in order to make them success. Uh, so first thing is we have a digital platform where one of the key thing we did is the distributed inferencing, and it is not very normal practice in the uh, ML world. So people try to do that, but they don't do it because for any video or anything to be uh, run parallelly and making sure that the video itself get generated, regenerated in a very quick time with the less cost, people tried different options, but they don't go on the distributed inferencing. We did it. What one of the thing we did is we able to generate 60% drop. The next thing is one of the channel marketing where we are serving major big techs. We are generating 3K content per day, and majority of them are 75 AI generated. It means essentially is our tool which we did built by the AI team and then maintained by the MLOps team kind of get succeed. Uh, Another is where we have one subscription management firm, uh, one of the leading in US. They do, and it's dashboard I showed you. They do 1 million payment per day. And right now, with the multi-model deployment with our MLOps team, we are able to fetch around 85% detection and 70% chargeback. Another aspect is another is a networking platform running for like 1 decades. One of the key thing we built for them, they have like 20-30 models running. And what essentially we did is majority of them is neural nets as well. And we provide completely support for them. And all they want is a very good bandwidth prediction. They don't wanted their consumer to see hallucinated prediction, which statistical prediction, which doesn't work, right? So that's their USP now. As a product, they're selling this as a key aspect. And right now, almost 1 million Wi-Fi clients are using this as a their bandwidth prediction. So these are our success stories. So now coming back to the conclusion. So what we have discussed so far, right? The very first thing is success is all about combining your data engineering and AI engineering, and this is what we are calling as MLOps, nothing else. Both AI and ML under this umbrella. Second part is your prompts and context management are your first class citizen. You have to figure out a way to improve them. And this is the only, after some degree of work and effort, your prompts become the gold and your context become your first thing to look for. Third part is the agent. Once this agent start working, they will become more smart and they will become more autonomous and they will start making decisions for you. So you will see the magic. That moment will come if you do things correctly. It will start doing the magic, right? So the example, the airline example I gave you, very quickly I was able to do the cancel. Yes, 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 and done. Right. So that kind of agents we need. Uh, Again, Alakh is already talked about is I'm just concluding it. the AI system doesn't fail. Their failure is kind of their nature because it's undeterministic. So if you don't do all this peripheral activity seriously, you will just if you just focus on your core, don't focus on your peripheral, there is a very high chance that you will end up in a loop and you will say AI don't work. Okay, but the, now the AI tools are kind of for last 1 year are making a lot of sense in the market, and majority of AI tools are now at least in this year are getting succeed. Okay, so I think yeah, so we are done from the presentation
Okay,
perspective. Yeah, Mike, over to you.
great. Yeah, thank you, Ratnesh, and thank you, Alakh, as well. That was a real practical and timely overview of the critical role that MLOps can play in Gen AI, especially as more organizations move from AI experimentation into production deployment, right? We've used a lot of time. We're almost at the hour, so I think we have time for a couple questions. So let's move into our audience Q&A. And let's see. So, actually, I have a question. So, for Alakh, let's give you this one. So, a lot of teams still think of MLOps as something that you can add later, once the model's already working. So, at what point do you think should organizations start putting MLOps practices into place?
Mike, I would say like right from day one, because it's not just a post-production layer or even production layer. It's how you design whole system. Even from start, like we already discussed how we version experiments, so we can track reproducibility, right? And even while going to production, we have to build CI/CD pipelines. We have to add, monitor all those feedback loops. So if we have to wait until the model works, we might have to end up rebuilding everything because of the reproducibility, version tracking, and all sort of things. So this is the things like we have to start from day one while building AI system.
Okay, cool. Thank you. So, Ratnesh, you talked about prompts and context becoming first-class artifacts in Gen AI systems. Sorry. So, what does good operational discipline look like for prompts in practice?
So the number one thing is you need to move out your system prompt from the engineering code base to the operation side, maybe inside a tool, like I explained in the Firebase, all the agents definitions, their prompts were available, and you can go and fix it. That is the number one thing you have to do. Second is you need to do tons of prompts attack. So your system prompts who are uh, at the end handling everything, and designing building system prompt is a entirely different skill altogether. So it's not like asking chat gpt or your cursor to do something. It's entirely different skill set. You need to do tons of imagination, tons of upcoming things and back things. And once you are done with it, the very third part you need to handle is the security thing. Means you need to make sure that in your system prompts there are tons of instruction is written to safeguard your users from their privacy data or sensitive data. Yeah.
So, thank you. So, Alakh, many organizations are kind of still stuck in pilot mode with AI. What's the most common reason promising AI projects fail to make it into production?
So Mike, like as we discussed, the most common reason is not about the model; it's about the system around it. So like one example I gave from the real-time bidding domain where the constraint was 10 millisecond. If we will talk about just about the model part, like lot of model can solve that problem, but to handle the 50 billion requests per day under 10 millisecond constraint per request, it's like very hard to develop and integrate in existing systems. So overall, whatever teams build, right, it builds like something in isolation, which is like kind of separate things, building in notebooks and all sort of things. But that doesn't fit in real world constraints. So project usually don't fail because of just because of AI or model. They fail because mostly they fail because of how it is built or pushed in the production from day one itself, like how we are getting feedback loops, how we are getting kind of monitoring the performance degradation over time, how we are taking care of in the continuous loop, all sort of things, not just about the model.
Okay, thank you. Well, thank you so much, guys. This has been really an informative hour. I'm afraid that's all we have time for today. I want to give a big thank you to Alakh and Ratnesh for sharing their insights and their expertise with us today. As I mentioned earlier, we'll be sending you the presentation slides and the webinar replay, and to everyone who registered for this today, and you'll be able to revisit this session and share it with your teams. So we appreciate you spending part of your day with us, and we really hope to see you at a future Talentica webinar. Have a great day, everybody. Signing off.